Take a look a little bit at mean value theorem. Now, in a previous video, which I'll link up in the cards, I talked about Rolle's theorem. So remember what Rolle's theorem guarantees us. It guarantees us that if the function is continuous and differentiable and the y values at the endpoints are equal. That's a lot of guarantee, a lot of ifs, right? If this happens, if this happens, this happens. Then we are guaranteed a value on that interval where the derivative equals 0, meaning where the instantaneous rate of change equals 0. Now, mean value theorem is very similar, and Rolle's theorem is just a specific case of mean value theorem. So let's look at what mean value theorem says. It says if the function is continuous. Sounds pretty familiar, right? Because Rolle's theorem is just a specific case. So if it's continuous on the closed interval and differentiable on the open interval, then there is a value C such that f prime of C equals f of B minus f of A over B minus A. That might sound familiar to you, okay? It's saying there's a place where the derivative, the instantaneous rate of change, equals the average rate of change. I like to think of it as the slope calculus way equals the slope algebra way. Slope calculus way equals the slope algebra way. The slope of the tangent line equals the slope of the secant line. So let's take a look at a few problems and see if the mean value theorem would apply. So consider this function, 3 minus 5 over x. It's pictured below. Does the mean value theorem apply on the interval -1 to 5? So is it continuous? No. H of x is not continuous at x equals 0. Why? Because the denominator would equal 0. So mean value theorem doesn't apply. Okay, would it apply on the interval from 1 to 5? Is it continuous on the interval 1 to 5? Yes. Okay. Is it differentiable from 1 to 5? Yes, it is differentiable. So mean value theorem applies because h of x is continuous and differentiable. It's continuous on the closed interval, oops, and differentiable on the open. Okay, so what does the mean value theorem guarantee us on the interval 1 to 5? It guarantees us that there's a place where the slope of the tangent equals the slope of the secant. So let's draw that secant line from 1 to 5. From 1 to 5 would be here. There's my secant line. And what it's saying is there's a place where the slope of that secant line is equal to the slope of the tangent line. I'm going to do my best to drag it out here somewhere in there. Did you see how those are parallel? Same slope, right? That's what it's guaranteeing us. That if it's continuous, if it's differentiable, there's a place where the slope of the secant line is equal to the slope of the tangent line. So the last piece wants us to find that value, okay? So remember, we're doing the slope calculus way, which is the derivative, equals the slope algebra way. So let's find h of x, h prime of x. And I probably should rewrite my function as 3 minus 5x to the negative 1. That's going to be a little bit easier to take the derivative of. So derivative of 3 is 0. I'm going to move that 1 in front, that negative 1 in front, which will give me 5x to the negative 2, which will give me 5 over x squared. Now I want that at c, so h prime of c. I'm just going to plug a c in for x. Okay, then I'm going to find my slope algebra way. I've already got it drawn. So I'm going to do h of 5 minus h of 1 over 5 minus 1. So h of 5, and I've got the function here. So 5 over 5 is 1. 3 minus 1 is 2. And then 1. So 5 over 1 is 5. 3 minus 5 is negative 2 over 5 minus 1, which is 4. Let's see, that gives me 1. So now I'm going to set these two equal to each other. So I've got 5 over c squared equals 1. And now we solve. Multiply both sides by c squared so that c is equal to plus or minus the square root of 5. But on this interval, we're only guaranteeing the positive one. Square root of 5, which is around 2 point something something. That's what our mean value theorem guarantees us. Okay, let's take a look then at a couple more. We're going to explain why we can't apply the mean value theorem on this interval. Okay, so why can we not apply it to f of x equals x to the 2/3? And it's because f of x is not differentiable. We have dealt with this x to the 2/3 many times so far in our videos, but if you'll remember, it has a cusp. Then the cusp looks something like this, right? Got a cusp there. So it's not differentiable at x equals 0. And I'm going to put in parentheses a cusp. So we are reminded of why. Remember, if you want to do it analytically, you definitely could take the derivative and take a look at why x can't be 0 in that derivative. Notice that it puts a 0 in the denominator of the derivative. So that's a problem. Okay, and then our last one for mean value theorem, we want to find the equation of the tangent line of this graph on the interval 0 to pi at the point that is guaranteed by the mean value theorem. Oh, this is going to be fun. So we've got to find that value. Then we've got to write a tangent line there. So let's start with the derivative. That'll be 2 plus cosine x. And I want that at c. So I'm going to do f prime of c, which will be 2 plus cosine c. That'll be fun. And then I'm going to do f of pi minus f of 0 over pi minus 0. That'll give me my slope algebra way. So let's plug in our pi. That'll give me 2 pi plus sine of pi plus 1 minus, and then I've got 0 plus sine of 0 plus 1. And that's over pi. So I've got 2 pi. Sine of pi is 0. So I've got 2 pi plus 1 minus 0. Sine of 0 is 0 minus 1. 1 minus 1 is 0. 2 pi over pi gives me just 2. Okay, so I'm going to set these two equal to each other. 2 plus cosine c equals 2. So cosine c equals 1. Nope, equals 0. Excuse me. Had to think about that for a minute. And where is cosine equal to 0 on this interval? And that's at pi over 2. Okay, now here's what I need, friends, at pi over 2. I need a point and I need a slope. Because now that I've found the point, now I've got to go write the equation of the tangent line. So the point, so we'll do f of pi over 2, 2 times pi over 2. 2 times pi over 2 plus sine of pi over 2 plus 1. So that'll give me pi. Sine of pi over 2 is 1, so 1 plus 1 is 2. So my point is at pi over 2, pi plus 2. Okay, now I need my derivative at this point because I need my slope. So I need my derivative at pi over 2. Now remember, we've already found the derivative. 2 plus cosine pi over 2. Cosine of pi over 2 is 0, so that gives me my slope is 2. So let's write our tangent line. It's not going to be pretty. That is A-okay. So I've got y minus, now watch how I have to put that y value in there. Put it in parentheses so I make sure that minus is distributed, equals 2 x minus pi over 2. And that is my tangent line at the value that is guaranteed by the mean value theorem. Okay, and then I love this box. It kind of just recaps the mean value theorem. Remember, you got to be continuous and got to be differentiable. And then I want to add, do that. It guarantees us that the slope calculus way is equal somewhere to the on that interval to the slope algebra way. So I hope that helps with mean value theorem. Thanks so much.